went through and everybody reported which of the different little wage cards they had gotten. That's how we came up with this table and our probabilities. We had 18 people that responded. Oh, I'm sorry. There, you can finish Ty's test.
I'm glad.
Yeah, yours was right underneath hers. There you go.
Thank you.
You're welcome. And then we found the expected value. When we have a random variable, when we have different possible outcomes and the probabilities of those different outcomes, the way we calculate the expected value or the mean, we're going to take the value, the possible outcome, multiply it by the probability, plus the value times the probability, plus the value times the probability, until you've gone through all of these. This is for discrete random variables. And then we've gone through this. We found standard deviation. To find the standard deviation, you want to figure out how far away is that value from the mean. You square it to force it to be positive. You multiply it by the probability. And then you add all of those, we call them weighted distances, and you square root at the end. When we did this before, just with straight up values, not random variables, we found our distance from the mean, we squared it, we added them all up, then we divided by n minus 1. When we multiply by these probabilities, that takes away our having to divide later. And then we interpreted our standard deviation. We got a standard deviation of 5.26. If I'm talking about dollars, I need to take that to the closest penny so that it makes sense in context. Standard deviation is always telling me how far away, typically, any of these things that we're looking at are away from the mean. So in this case, we're looking at wages. Typically, how far away are the wages from the mean? And we found that they are typically about $5.27 away from the mean. They're going to be within that range. And if I look here at the possible values for x, we got 10.06, so just a little bit up here. If I add $5 to that, that puts me to 15. If I subtract $5 from that, that puts me just a little bit above 5. So that gathers most of the possible wage cards. And especially as we look at the probability distribution on the bottom, that captures 16 out of 18 of those wage cards. So most of those wages are falling within $5.27 of our average, of our mean. All right, I said we were going to answer question 5. So Mrs. Gallus decides she would rather assign wages so that employees could get any amount from $10 to $20, and all are equally likely. Equally likely. Maya, give me just a second. I'll get you a new notes packet. We're going to draw a graph to represent this probability distribution. If I have equally likely outcomes, think about what a histogram of this would look like. Would it have a shape kind of like this if all the outcomes were equally likely, if I have my probabilities over here? What should the graph look like if the outcomes are equally likely? What'd you say? A rectangle. It's going to look like a rectangle, absolutely. So I'm going to draw this slightly prettier looking. So we want to go from $10 to $20. So my probability distribution is going to have this rectangle shape to it. What should the area underneath the curve be? 1. Should always be 1 so that it adds up to 100%. Area under the curve is equal to 100%. So if this area is 1, how high up does this rectangle go? 1/10. Why? Yes, there's a difference in wage of $10. This is always going to be 1 over, and then we're going to grab those two guys. In this case, that would be 20 minus 10. We grab these two pieces right here. What is the probability that an employee makes between $12 and $12.50? So if I look at my graph, $12 is going to fall about where? What'd you say? Closer to the 10. So we'll put $12. I think I'm going to put a little bit further over. Because $12.50, hold on, 15 would be here. $12.50 would be here. So $12 is going to be a little bit back from that. So here's $12. Here's $12.50. To find the probability, I want to find the area of that rectangle right there. To find the probability, we need to find the area of the rectangle under the curve between 12 and 12.50. So how am I going to find the area of that curve? Area of a rectangle is what? Length times width. What is the length of that rectangle? 0.5. And my width? 10? 1/10, sorry. Would it matter if I flip those around the other way? No, we're multiplying them. So if you called 0.5 the width and the length 1/10, it does not matter. Yes. 0.5. We need the length in between 12 and 12.50. So if I do 12.50 minus 12, that's how I get that. Because I want to go in between those two. Does that help? Awesome. So what do I get when I multiply those two together? What did you say? 1 out of 20, or 0.05. So remember, we need to write our probability statements. You guys did a pretty good job on that on the test. Probability that our random variable, which I'm going to call x, is between 12 and 12.50 is equal to 0.05. And again, we're getting that from the product of 0.5 and 1/10, or 0.1. If I'm not given a name for my random variable, I'm going to use x in its place. So far, so good. Do you guys remember doing these probability density functions that look like this? Does anybody remember what it's called? It's called a uniform density function. Uniform because the probabilities for all of them are exactly the same, all the way across. All right, go ahead and flip this over. To find the standard deviation of a discrete probability distribution. What does that symbol right there mean again? Sum. So we're going to add a whole bunch of things up. We do each of the possible values for our random variable minus the mean. This is my expected value. Multiplied by the probability that goes with that possible outcome for our random variable. If you don't square root it, if you do all the stuff under here but you don't square root it, we call that the variance. Once you square root it, it's the standard deviation. Before you square root it, we call it the variance. Probabilities for continuous random variables. The difference between a discrete random variable and a continuous random variable. Discrete random variables are like those wage cards. What were the possible options for your wages? Does anybody remember? 1, 5, 7, 10, 15, and 25. Those were the only options. Could anybody, based on the cards that I handed out, make $20 a day? No, why not? That wasn't one of the options. What about $12? Not one of the cards. $12.50? Not one of the cards. That's what we mean when we talk about a discrete random variable. It can only take on certain values. In this case, it could only take on the values that I had written down on those cards ahead of time. For a continuous random variable, it can take on any value in between there. So when we looked at that uniform density function on the other side, talking about being able to make between 12 and 1250, this is a continuous random variable here. Because somebody might get a raise and they might suddenly make 1205 or 1210 or 1222. You have all the values in between, not these discrete ones that were written out ahead of time. Does that make sense? We talked about another kind of continuous random variable earlier in the semester. Do you guys remember drawing our normal curves? They're back. They are not going to go away again until you take that exam in May. So get very familiar with drawing your normal curves. When we draw a normal curve, the mean, the expected value, goes right in the dead center. Remember, you're going to put your standard deviation. You want that little bar to come across like this. And you're going to label that as your standard deviation. You need to label your normal curve with a capital N so that anybody else looking at it knows that no matter how bad your artwork happens to be, it's supposed to be a normal curve. That's what the importance of that is. And then you're going to put what your expected value, what your mean is, and what your standard deviation is. You can use normal CDF on your calculator to calculate those probabilities. Do you guys remember how to do normal CDF on the calculator? All right, let's walk through it one more time again. To be able to calculate values for normal distributions, stat, oh, hold on. Give me just 1 second. I gotta find this again. Stat, calc. Where'd my normal CDF go? Hold up, I gotta go find it again. There we go. Sorry, I found it again. Second and vars, not second stat. Second and vars should be located somewhere near your arrow keys. Second and vars. The second option down is normal CDF. When you choose that option, it's going to open up parentheses for you. Do you guys remember looking at that? Does that look familiar at all? The first number that you enter is going to be the lower bound. So when we were doing our uniform density function, this is where I would put the 12. Then you put your upper bound in, so that would be like the 1250. Then you put in what your mean is and your standard deviation. All of these need to be separated by commas. Remember, the comma key is right above the 7. So lower bound, upper bound, mean, expected value, and then standard deviation. Close the parentheses and hit enter. And it will give you what that probability is. When you decide to do it on your calculator, you have to write this on your paper so that I know you use the calculator to do it. You write normal CDF. You're going to put those 4 numbers inside the parentheses. And underneath each of those 4 numbers, you're going to label what they are. Because again, some different graphing calculators have you do them in a different order. This means that no matter who is looking at it, no matter who is grading that AP exam in May, they know which piece you are saying is the lower bound, which piece is the upper bound, which piece is the mean, which piece is the standard deviation. So far, so good? All right. I want to give you guys, take about 5 minutes to do the check your understanding down at the bottom. You're going to have to draw some normal curves there. We'll go over this together here in, like I said, right about 5 minutes. Yeah, absolutely. If it doesn't work, let me know. Go quickly. Here, let me give you a pass. What type of variable is y? Is it discrete or is it continuous? Continuous. If it's discrete, it can only take on set predetermined amounts. If you think about how long somebody plays Minecraft for, they might play it for 5 minutes, they might play it for 5 minutes, 30 seconds. They might play it for 1 day, 7 hours, 32 minutes, and 14 seconds. It can take on any of these values. If it can take on any value, it's a continuous random variable. If it can only take on specific predetermined amounts, then it's a discrete random variable. So it is continuous. Any value between 0 and, in this case, 1,440 minutes, 24 hours, because we're looking at how long they play in a day. Interpreting the standard deviation. What is the standard deviation? Yeah. They gave it to us on here, 42.7, right? How would you interpret that? What does that 42.7 mean? Yes. Of what? What was the mean? Yes. So on average, or typically, the amount of time spent playing Minecraft varies by 42.7 minutes from the mean of 150 minutes. The way you organize that sentence can be a little bit different. Like you could say, it typically varies 42.7 minutes from the mean of 150 minutes for playing Minecraft each day. As long as you have your context in there, what are we talking about? One of the ways to definitely guarantee you're getting context in there is to put units. But in this case, you wouldn't just want minutes. Minutes doing what? So minutes playing Minecraft. When we say that it varies by 42.7 minutes, it can go on either side, plus 42.7 or minus 42.7 or anything in between there. Wanted you to find the probability that y is less than or equal to 90. So the very first thing you need to do when you are working with a normally distributed random variable, I know that it's normally distributed because it says it right up here. Normally distributed. First thing we need to do when you know something is normally distributed is what? Does anybody remember from before? Show me your art skills. You're going to draw. You need to draw the distribution. I have a little bit more on my drawing than you have to have, but things that you must have. You must have the mean labeled, so right down the center. You need to have the standard deviation labeled. Including these other pieces in blue is optional. I just added the standard deviation 3 times over here and subtracted it 3 times on the other side. You do not have to do that. You have to show your mean. You have to show your standard deviation. You have to show that it is normal, so capital N. Put your mean and your standard deviation inside parentheses. It is usually a good idea to label those. Mean and standard deviation. The other thing that your picture has to have is what is it that you're trying to find? What is it that you're interested in? And then we're going to shade it. We wanted to know the probability that our random variable y was less than or equal to 90. So I put 90 on this graph. It obviously had to be less than 150, so I put it to the left of the mean. I drew that line in there. You can hardly see it, but down at the bottom, I marked that as 90. You do actually have to say where that is so they know you didn't just like accidentally scratch something on your graph. And then you shade everything in the direction of your inequality. So I shaded everything below 90. How would you calculate this probability then? Tell me what we're going to put in. Normal CDF. Yes, hold on just a second. My thing's messing up. So I'm going to do normal CDF. 0 is my lower bound, or you could go with negative 1,000, whatever. But if you're playing for 0 minutes, that's really the lowest this particular example can go. You can always put negative 9,999 in there. Upper bound of 90, because that's as high as we want this to go in the shaded space. The mean of 150 and the standard deviation of 42.7. You have to label these things over here. You can't just have the numbers, you have to say what those numbers mean. You hit enter on your calculator. There are 2 things that I need to see after you hit enter on your calculator. One of those things is the probability statement. This is what we're finding the probability of, and so you need to have that and then your equal sign. And then I got 0.798, or about 7.98%. Is the calculator the only way you can do this? How else could you get the same or close to the same answer as this? If you weren't going to use your calculator, what else could you do? You guys know those formula sheets you keep passing out for tests? After that first page, what's all the rest of it? Z-scores and tables. You could do a Z-score for this. You could calculate your Z-score and then look it up in table A if you don't want to do it on your graphing calculator. This is what that would look like. First, you would have to normalize. So y minus 150 over 42.7. This is what my z is. Z is equal to y minus the mean over the standard deviation. And then I would take the value I'm interested in, 90, minus 150, my mean, divided by the standard deviation. I got that z is less than or equal to negative 1.41. I looked that up on the table. I got 0.0793, which is very, very close to what I got from the calculator. Interpreting this value, what does that 7.98% mean? What does it mean? What does the capital P mean right here? Probability of, what does y mean? Yep, amount of time spent playing Minecraft in minutes. So the probability that a randomly chosen player plays Minecraft for 90 minutes or less is what? 7.98%. There's a 7.98% probability of choosing a Minecraft player who plays 90 minutes or less a day. Sorry, I'll get that right back up. There we go. Part D, they want me to find the probability that y is in between 45 and 90. First thing you do if we're looking at a probability with a normal distribution, what's the first thing I want to see? Draw. I want to see your artwork. I want to see a normal curve. So I redrew my normal curve. You have to have the mean on here, so you have to have 150. You have to have your standard deviation. You have to have n for normal and the mean and the standard deviation in here. The other thing that you have to have on your picture are these values that you're looking for the probability of. So I had to have 90 and 45, and I had to shade in between. When you're finding the probability for a normally distributed random variable, and it is in between two values, the fastest way to do this is with your calculator. Table A is going to take forever because you have to calculate both of those from table A, and then you have to subtract them. If you do it on your calculator, it will do all of that work for you. You can just type it in just like you typed the last one in. It's due. It's due tomorrow. Because we got it on Monday. How would you calculate this? Tell me what you would write down or what you would type in. Yes. Yes. Normal CDF, lower bound of 45, upper bound of 90, mean of 150, standard deviation of 42.7. Close your parentheses. Remember to separate each of these numbers by a comma. That should be just above your 7 key. That's where the commas are. So the probability that our random variable y is in between 45 and 90, I got 0.0730 on my calculator. I only took that out to 4 places. Remember, probabilities we typically will take out to 4 places so that when you change them into percents, it's a percent with 2 decimal places behind it. If you use table A to do that, you would have to normalize both of those values, and then you would have to subtract those. When I did it with table A, I got 0.0724, which is very, very close to what I got from my graphing calculator. How would we interpret that value, that 0.073. How would you interpret that in context? Yes. There's a 7.3% probability of selecting a Minecraft player who plays between 45 and 90 minutes a day. One piece of vocabulary that I want to make sure to talk about, just because I've seen it happen a couple times, I don't know how precise they would be on this on the AP exam. So please don't take this as gospel truth. But using chance and probability interchangeably is almost always okay. Odds are different. So I would not put the odds of selecting a Minecraft player. Odds are something that is similar. It's related to probability, but it's not the same thing. So I would not use that particular word. I want to have you guys write down just a little tiny bit more that's on the next page. We're going to finish it up tomorrow. I am going to pass back your tests so that you can see how you did on those. But the first thing that the next page wants you to do, page 7, is to recopy our table from page 5 and the mean and the standard deviation.
Just write down the desk.
Thank you. We will complete the rest of this activity. Is it time for a raise tomorrow in class? I'm going to go ahead and pass back those tests.